So where did we stop in the last class? Oh, okay. I'm just looking at these messages. Fine. Nishita, the link won't change. Every day the link is going to be same. Yesterday also the link was same. Every day the link is going to be same. So it won't change. You can check the meeting ID. So it will be same every day till the end of the course. By any chance, if I change it, I'll inform you people beforehand itself. Okay. So meeting link is same. Nishita, hope you got it. I just saw the message. Meeting link is going to be same. Every day it will be same. Okay. So let's start. Before that, I request you people to please mute your mics, all of you. Please mute your mics. Please mute your mics. I guess Surya, your mic is not muted. So today we'll start with the associations itself. So what are they? We'll talk about composition and aggregation. Composition and aggregation. So first we'll start with composition. So this is a special case of association. Again, okay, it's one type of association I can say. Yesterday we saw simple associations. So today we'll see composition. This is one type of association I can say. Yes. So good morning, good morning. Okay. So can someone tell me or explain this composition? Is anyone familiar with it? Oh, Sai, just drop me a mail, man. I'm sorry. And one more thing. Yesterday I created a group, WhatsApp group, and whoever has shared the number with me, I have actually added you to the group. I guess Praneeth, and is there anyone else? Sagar, did you join the group? I'm not sure. Sankeet, Srinivas. So make sure that you people send me your numbers if you didn't do that. So I will share the. Sorry, I will add you to the WhatsApp group. Okay, for instant messaging and all. Okay, just make sure that you send the numbers. Mail me your number. Okay. Yes, I'll add you people to the WhatsApp group. Okay, so let's talk about composition and aggregation. First, I'm sorry, we'll talk about aggregation. I'm sorry, I said I'll start with composition, but we'll start with aggregation. So what is aggregation? You see, aggregation, it represents association between the objects again. It represents the association between the objects. But you will find that, you see, aggregation is a special case of association here, in which where an object is part of another object. If one object is part of another object, then I can say that these two objects, the association between these two objects is aggregation, I can say. Okay, if an object is part of another object, then we can say the association between these two objects is aggregation. Example, wallet. In a wallet, you'll have money. Laptop and speakers. Mobile and memory card. So these are the associations, examples of associations here, like aggregation especially, I can say. These are examples of aggregation. These are examples of aggregation. Here, how will you represent this association? So what, how will you represent, or how can we represent this association, that is aggregation, in the programming here? So what do you people think? What to do? So we need to define a class for, let's say for example, if you take this mobile, we'll take mobile and memory card. So we'll define a class for mobile, and you see mobile, what will be the properties of a mobile? What will be the properties of the mobile? The properties of the mobile will represent them as variables here, right? Yes. What will be the properties of the mobile? The properties. Uh, no, no. Mobile will have a color. Okay. Yes. Okay. Mobile will have a brand. It belongs to a company, right? A brand. Mobile has got a name. Mobile has got processor in it. So the processor details. What is the name of the processor? And what else? Mobile has got a battery, and what else? A battery name, whatever it is. So this way, even battery again can be an object. Again, I'm just showing you people something, some details here. In this mobile, what is the OS name? Let's say operating system name, and mobile has got color, right? Mobile has got screen dimensions. So this way, you may have several fields. Actually, to be frank again, so they would become more complicated if we can identify, or if we properly define this completely based on the object-oriented concepts. For example, processor will be another object, battery will be another object. Okay, color will not be an object again. Screen can be an object. Why processor will be an object again? Can you people tell me? Why processor will be an object again? Why the processor is an object again? Yes, because processor again, it has got its own properties and behaviors, I can say. You know, processor has got its own properties and behaviors. Yes, so it is complex enough to be called as an object. Yeah, so processor, it belongs to a company. Processing capacity, like uh, like whether it is again a quad core processor or a dual core processor, whatever it is, right? How many instructions per millisecond it can execute, the number of instructions which it can execute per millisecond. We have something like throughput and many other things. Okay, but okay, as of now, we'll not go into details. Let's say when we consider a mobile, so these are all the things which you'll see. Okay, yes. Okay, next, again, in the mobile, you can have a memory card, or we say memory card, right? Memory card. So, memory card again, it will have a name. It is what type of memory card. Capacity, storage capacity will be there, and brand, and so on, like that. Nowadays, you have transfer speeds also. Yeah. So now, how can we represent the association between these two objects, the mobile and memory card? How can we represent the association between these two objects? Again, you will use a reference here. Okay, no matter it is what type of association, always the associations here, you'll represent them using references. So in the mobile, I can add a reference, memory card, a reference variable of type memory card. That's it. So mobile will hold the reference to the associated memory card object, right? So now this is aggregation. So mobile has got a memory card in it. Mobile has got a memory card in it. This is an aggregation, I can say. Okay. So hope this is clear for everyone. Anyone got any doubts or issues in this regard, please let me know. No, you see, I'm saying in case of aggregation, you see, where when an object is part of another object, we are saying aggregation is a case, is association here between the objects where one object is part of the other object. Money, you will put it in a wallet, you'll have money in the wallet. Memory card, you'll insert the memory card in the mobile, it will be part of that object, mobile. Speakers, you'll have inbuilt speakers, though they are inbuilt, they have to be added, and you can remove them separately again. But we saw another type of association in the last class. I was talking about associations like savings account and account holder. If you consider savings account and account holder, can I say that okay, account holder is part of a savings account object, or account a savings account object is part of account holder object? Can you describe the association that way? In the examples which I gave you people yesterday, if we consider those examples, can we describe them? Can we describe the associations this way? Can I say that okay, savings account is part of that account holder object? No, we cannot. It is not the case. But yes, they are associated, but I can't say that one object is part of another object. I can't say that one object is part of another object. That is not an aggregation. It's an association, a simple association. You see, even there is an association between you and me. What is it? A student and a faculty association. It's a very formal association, that's it. Okay. So we interact with each other. There is a purpose. Now you people are linked to me, right? Till the end of this course. That's it. So hope this is clear for everyone. Still anyone got any doubts in this regard? So this is aggregation. And yesterday we saw a simple association. In aggregation, one object is part of another object. Okay, an object can be part of another object here. Not can be, it is part of another object. So here you see, I can say that the laptop or mobile or wallet, they are container objects. You can consider them as container objects. You see here, mobile is a container object, I can say. Laptop is a container object. And what else? Your wallet is a container object. Container object means an object which can hold other objects. Okay, or it is made up of other objects. So in the mobile, you'll have SIM card, you'll have memory card, you'll have screen, you have battery. Okay, yes, these are container objects. And contained objects are, what are contained objects here? Your memory card, money, or notes. Let me say money, that's it. And what else? If it is laptop, speakers. Okay, container and contained objects. Yes. Okay, now we have composition. Composition. Let's see composition. So when we talk about composition, composition is a special case of aggregation. It is one type of aggregation itself. Composition is one type of aggregation, you can say. But you see, when an object contains another object, if the contained object cannot exist without the existence of a container object, then it is called composition. If the contained object cannot exist without the existence of a container object, okay, yeah. So you see, we have a battery. A battery, can it exist without a mobile? Okay, is there any purpose for that phone battery without a mobile? No, right? And you see, SIM without a mobile, SIM cannot exist. Okay, almost the existence of SIM is of waste without a mobile. Employee and a company, and you see, heart, lungs, brain, they cannot exist without a body. So these are examples of composition. You see, contained objects, that means battery is contained in mobile, SIM is contained in mobile. Employees part of a company. Employee cannot exist without a company, right? Yes. And heart, lungs, brain also cannot exist without a body. Can I say mobile and memory card is an example of composition? Can I say mobile and the memory card is an example of composition? No, because you see that memory card, that contained object can exist. That memory card, you see, we can add it to a card reader and we can use it, right? Card reader, you can add it to a card reader also, can use it. You see, SIM, you can't use it without a mobile. You need a mobile. Okay. Yes. Memory card, you can add it to SIM, or you can add it to a mobile, or you can add it to a card reader, and you can work with it. Still, it works. Okay. So, can you people give me one more example of composition? You see, even these examples which we saw in aggregation, like money and wallet. Yes, contained object is money. Money can exist without wallet. There is no issue, right? Not everyone will use wallets. Okay, speakers also can exist without a laptop. You can connect to anything, right? Steering, yes, you see, we can't use it. Wheels, steering, yes, okay, yeah, maybe, yes, that's right. And yes, there should be some entity, always a savings account, but you see, that is not an example of composition or aggregation. We are talking about composition. That is what you need to understand. Still, I guess you got the confusion. I'm talking about composition here. Okay. container and contained objects. That is what our discussion is here. Okay, so operating system cannot exist without a laptop. Okay, it executes in the laptop itself, right? Okay, yeah, yes. I guess hope you people understood this. Now, you people can try implementing these examples, define the classes for these objects which I've mentioned here. Okay, so let's move on. We'll move on to the next topic. So these are all the things which are related to the object oriented programming. Today, I'm going to talk about object class. So object class is a very important class for us. So let me talk about this object class. Is anyone familiar with the object class? You know, in Java we got a class called as object. Yes, can someone talk about this object class? So superclass, okay, inherits object class, superclass of all classes. Okay, yeah, yeah. Actually, you will find that object class is considered as superclass of all the classes in Java. Object class is actually considered as superclass of all the classes in Java. Just a second, please. Just a second. Sorry. Okay. So object class is considered as superclass of all the classes in Java. So each and every class directly or indirectly inherits object class, I can say. Each and every class directly or indirectly extends object class. So what is the importance of this class? Why every class is made to extend object class? Let's see. First of all, let me open the Eclipse IDE. Just a minute. Let this IDE load. Okay. So we have this test class here, right? You know, can I say that test class extends object class? I can say yes. But we didn't make it to extends object class, right? The test class, it doesn't extend object class. But still, I can say that test class extends object class. How? Because you'll find that during the compilation, during the compilation, the compiler, if it finds that this class is not extending any other class, it will simply make this class to extends object. The compiler will simply make this class extends object. That's it. Okay. So compiler will make this class to extend object class. Yeah. During the compilation, the compiler, if it finds that this class is not extending any other class, you see, the test class is not extending any other class, right? So the compiler will make this class to extend object class, I can say. If the class is not extending any other class, so by default, compiler will add extends object. Okay. Hope you got it. So this is what happens during the compilation. Object class, I can say that, is the super class of all the classes in Java. Every class directly or indirectly inherits objects. Next, during the compilation, if the compiler fails to find during the compilation, if the compiler finds that the class is not extending any other class, then it will make it extends object class. Okay, during the compilation, if the compiler finds that the class is not extending any other class, then it will make it extends object class. Okay, now you see, for example, what if the class is already extending what if the class is already extending some other class? For suppose, let's say you have junior savings account class. It extends savings account class. So in this case, what happens? You see, yes, in this case, junior savings account class, you see, the compiler, it cannot make it extends object. Yes, that's right, exactly. In this case, the compiler will not make this class extends object class. But you will find that the compiler will add extends object for the savings account class. Super class is not extending any other class, right? So the compiler will make savings account class extends object class. Compiler will make savings account class extends object class. This is what happens. Okay. Yes. Why every class is made to extend object class? Is anyone aware of this? What do people think? Why every class is made to extend object class? You know, I can say that actually object class is the object class has got methods. The methods of the object class, I can say that they represent the most common operations which we perform on the collections. Okay. In the object class, we got methods which represent the most common operations which we perform on the objects. So let's try to inspect this methods once. We'll go through this methods. See, these are the methods which you'll see in the object class. What are those methods? I'll read out the methods. Get class, hash code, equals, clone, toString, notify, notify all, wait, and finalize. So each method it represents a functionality or an operation I can say which we can perform on the collection. Yes. On the objects, I'm sorry, not on the collection. So now let's start exploring this object class methods. Let's see what functionalities they provide. So how to make use of this object class methods. Okay. As a Java developer, you have to be familiar with this object class methods. It's very important. You see, to make you people understand the object class methods, I'll consider the item class. Let's say we got the statements here. You see, we are creating two item objects, right? You'll find that here in both the objects we got the same data. In both the objects we got the same data. Now, definitely these two are different objects, but they got the same data. That means item 1 and item 2, these are two reference variables which are referring to two different objects, I can say. We are referring to two different objects. Okay. Okay. How do I check whether these two reference variables are referring to the same object or different object? This is where you can make use of relational operator. You see, I can do this. Item 1 double equal to item 2. Item 1 double equal to item 2. You see, these two reference variables, if they are referring to the same object, if they are referring to the same object, then you know this relational operator returns true. The relation operator returns true. Otherwise, it returns false. So in this case, will it return true or false based on the discussion? What do you people think? Will it return true or false? I said the relational operator will only check whether these two reference variables are referring to the same object or not. Say as I told you people, you have two different objects here. The only thing is both the objects have got the same data, but objects are different here. I'm talking about Java objects. Okay, you have two different objects, but the data which is stored in those two objects is same. So this relational operator will only check whether these two reference variables are referring to the same object or different object. So in this case, they're referring to two different objects. Objects are not same here, they're different. But the data which is stored in those two objects is same. So in this case, it should return false, not true. In this case, it returns false. Yes, you got the point, all of you. I'm talking about the software objects, Java objects here. Okay. So one thing you need to notice here is that the relational operator, it is not comparing the data in those objects. That is what I'm trying to explain. Please listen to me carefully. So the relational operator is not trying to compare the data which is stored in that objects. It is only checking for the references or objects here. Each time we use a new keyword, JVM creates an object. It allocates a block of memory, right? Don't forget that fact. Don't go with the data. Don't go with that figures or data. Data has got nothing to do now. We are talking about objects. So we create objects using new keyword. So how many objects are created here? Yes, can you people tell me? If I execute these two lines of code, how many objects are created? Two objects. How you are saying true? So item 1 holds a reference to first object. Item 2 holds the reference to second object. The only thing is in both the objects we are storing the same data. Okay, both the objects have got the same data. Yes, but of course item 1 and item 2, they are referring to two different objects. So if I compare these two reference variables, see it will return false itself because item 1 refers to one object, item 2 is referring to another object. Yeah. So relational operator will not compare the content or the data which is stored in that objects. Yes. So hope you people got it. Yes. So is it clear for everyone? Can I have yes? So it is not checking for the data in that objects. Now what if I want to compare the contents which are stored in that object? I want to compare the contents which are stored in that object. See, just a minute, please. Just a minute. Yeah, I'm sorry. So no, you see, uh, don't worry about extents and all now. It has got nothing to do with. It's very simple. I'm talking about two objects. That's it. Okay, we are comparing the references. That means objects. See, item 1 and item 2. You have the references stored in the reference variables. Okay, so we are checking only whether these two reference variables are referring to the same object or different object. That's it. The objects in the memory. Okay, the Java objects which are in the memory, we are just checking that. That's it. We are not looking at the data, superclass, subclass. Don't worry about all those things. Okay. Yes. Okay. So What if I want to compare the data? What if I want to compare the data? What to do then? Okay, that is what we need to do. Okay. Any other option? What do people think? Is there any other option? Yeah, actually, don't we need to use equals method, but not that way. I'll tell you. But before we move any further, so I would like to also show you people another example, so which makes the things more clear for you people. You know, in Java, as I told you people, we have a class called a string, and generally the string class objects are basically used. String class objects are used to store string content. String class objects are used to store the text content, I can say. String class objects are used to store the text content. So we can create a string class object this way. You see, I'll instantiate it. I'll do this. Let's say hello, good morning. So if I do this in this case, how many string objects are created in this case? How many string objects are created in this case? Two string objects are created. In both the string objects, we got the same data. In both the string objects, we got the same data. Okay. So now we'll try to compare these two string objects using the relational operator double equal to again. I'll do this. S1 double equal to S2. So what you'll get, true or false? What you'll get, true or false? Okay. Yes. Did anyone say true? Hope no, right? Yes, definitely it will be false, not true. Okay. Let me show you people. So beginners in Java, they try to compare the strings this way. You'll get false. You should not do this. Do not try to compare the string objects this way using relational operator double equal to. It returns false itself. Then how to compare the contents of the object? That means what data you have in that objects. I would like to compare that content. Then what to do? So this is where we'll be using equals method. This is where we'll be using equals method. So you see, I'm using one of the object references to call this equals method, and the other object reference I am passing it explicitly to the equals method. Sorry. So the equals method, where it is defined actually, it is in the object class. It is from the object class. Equals method is from the object class, I can say. So you'll find that the equals method here, it will compare the contents of these two objects, and it returns true here. You see, this time you're going to get true. So this is the first method now, which we are using from the object class. Equals method is defined in the object class. You see, here it is. Okay. Now, can we use the same equals method for the item objects also? Let's see. Okay. We'll try to compare the contents of the objects using equals method. Item object contents, we'll try to compare them using equals method. The relational operator is not failing. It didn't fail. It's perfectly working fine without any issues. Why it fails? It's not failing. It is checking whether that reference variables S1 and S2 are referring to same object or a different object. You see, S1 was referring to one object, S2 is referring to another object. So when you compare the references, of course, they will be different. You'll get false using relational operator. Relational operator will only check for the references. You got it? Whether they are referring to the same object or not. So now, if you want to compare the contents or data in the object, you'll go for equals method. Yes. Now let's try to use equals method here in this case. Okay. So we are trying to compare the contents of these two objects, item 1 and item 2. So let's see what happens. But in this case, it returns false. Equals method, it returns false. But the data is same. The equals method is supposed to compare the contents, right? According to our assumption, you see, we saw that in case of string objects, it was returning true because the content is same. Yeah. But there is one important thing which you need to know, all of you. By default, in the equals method, you will not have the functionality to compare the contents of the objects. You have to write that functionality. In the equals method, you will not have that functionality to compare the contents of the objects. Equals method of the object class, you'll find that by default object class equals method functionality is same as double equal to operator. It is same as relational operator double equal to. It is same as relational operator double equal to. By default, object class equals method functionality is same as double equal to operator. That means, you see, this equals method, we didn't define it in the item class, right? Did we define the equals method in the item class? Can you see this equals method in the item class? No. You will not find it. We are inheriting it from the object class, and the object class equals method functionality is same as double equal to operator. Okay, if it is same as double equal to operator, fine, then it is working fine. It has got that functionality. It is checking this to reference variables. It returns false. Okay, good. In item class, in case of item class, it is fine. It works perfectly without any issues. But why it is returning true in this case? I'll show you people. Don't get confused. Just concentrate. Try to make a note of these points. Later on, you can just relate them. You see, if I use relational operator to compare these two references, it returns false. Down you can see the result. If I use equals method to compare these two objects, it returns true. That means what we can analyze, can I say that equals method functionality, it is not same as double equal to operator in case of string class. In case of string class, it's not same as double equal to operator. Can I have yes, all of you? Can I have yes, first of all? It's not same as double equal to operator. But I am saying that I gave you a point here that equals method functionality will be same as double equal to operator. But that is not the case in this case, in case of string class. But if you consider the item class here, I'll show you people. If you use equals method, the functionality will be same as double equal to operator. You see, in both the cases you'll get true. You'll get false. In both the cases you'll get false. So it is same. In both the cases you're getting false. That means what we can analyze here is that when it comes to string class, equals method functionalities changed. That is what you need to understand here. That is the main important point which I'm trying to highlight. What happened here? In the string class, equals method functionality has changed. How come it is possible? It's not same as object class method functionality. How it is changed here? What do people think? Or why it is changed? Why the equals method functionality is changed here in the string class? Is there any possibility? If so, what is that possibility? In the super class, I said in the object class, this is the functionality. It is same as double equal to operator. But in the string class, which is a subclass, the functionality is changing. How come it is possible? You know the concept actually. Think about it carefully. In the superclass, we have one functionality. When it comes to a subclass, it is changing. The functionality is changed for that method. Yes, that's right. Overriding concept. Here, the answer is overriding. Yes. You know, the subclass is modifying or it is changing the superclass method functionality by overriding it. Subclass is overriding that equals method. Subclass means here I'm referring to string class. So string class is overriding equals method such a way that it compares the contents of the objects. String class is overriding the equals method such a way that it will compare the contents of the objects. I'm sorry, you can make a note of it if you want. String class overrides the equals method of the object class in such a way that it compares the content or data in the objects. String class is doing it. Not only string class, every class is supposed to do the same. Not only string class, but every class is supposed to do the same. Even in our class, in the item class also, we have to do the same. We have to override that equals method such a way that it compares the contents of the objects. Okay, so let me do this. We'll try to override that equals method in the item class also. See, now what is the functionality or the code which we are supposed to write here? What code we need to write while overriding this method? Yes, what is the code we are supposed to write here? Yes, we have to write the code to compare the contents of that item objects. You see, the equals method, how it is invoked, just check once. It has to compare the contents of two item objects here. It has to compare the contents of item objects. You see, one of the object reference is used to call the equals method. The other object reference is passed explicitly. Okay, so the object reference which is passed explicitly, you see, we can take that object reference and you can store it here in a reference variable. It is in superclass reference variable, right? You can cast it to subclass type. Now the question is, how can we read the object reference which is used to call the equals method in the equals method? In the equals method, I want the object reference which was used to call this equals method. how can we obtain that object reference which was used to call this equals method? You people know that concept. You're definitely aware of it. How can we do that? Yes, exactly. This. So this will give you that object reference, the reference to the object which was used to call that method. So that current object reference we say, you see, by using this object reference, we are asking the equals method to operate on this object. So that object reference is passed on to that equals method implicitly, and it is stored in this variable. Now you see we have both the object references. One of the object reference is passed explicitly. You see that item 2 is passed explicitly. So we got both the object references. Let's try to compare them. So item 1 dot will compare that content if it is equal to item 2 dot id, and item dot price, sorry, item 1 dot price if it is equal to item 2 dot price, and item 1 dot name is string type. If you want to compare strings, what you are supposed to do, use equals method. Item 2 dot name, I can say item 2 dot name. Okay, they should be equal. Just a minute, please, just a minute. Yeah, I'm sorry. So you see, we are comparing the contents of these two objects. We are comparing everything here. If it is same, then we'll return true. If all these conditions are satisfied, then we'll return true. Otherwise, we'll return false. That's it. Okay. So this way we have to override the equals method, such a way that it compares the contents of the top item objects. So now this time, if I run this code, okay, first statement will return false, of course, no doubt. What about the second statement? Will it return true or false? This statement this time, will it return true or false? It should return true this time because we have overridden that equals method. So we are now this equals method of that item class will be invoked. That overridden equals method will be invoked. You see, it returns true. It returns true. Yes. So this is how you have to use the equals method of the object class. So is it clear for everyone? Yes, definitely. You see, we are just passing the references here. Now, if you interchange the references, no, it won't be a problem. Okay, just you're interchanging the references. You see, the reference variables here need not be item one, item two. You can make it I1, I2 also, and here accordingly use them. I1.id equal to I2.id, something like this. In fact, we don't need to again declare this variable like this. You can directly use this dot id, this dot price, this dot name. Okay, but because you're somewhat new to this coding, so I'm doing this here. That's it. The variable names in the equals method need not be item one, item two. Okay, so is it clear for everyone? So anyone got any questions, please let me know. Okay, I have a question for you people. Maybe you don't have any questions, but I have a question for you people. So what is the question? My question is here. Just a second. Sorry. Here, you know what? Why we have to use this equals method to compare the contents of the objects? Why we have to use equals method only? Can't we define our own method to compare the contents of the objects? Can't we define our own method to compare the contents of the objects? What do you people think? We can do it, right? Then why to use equals method? What is the advantage of using equals method? You can define your own method also to write that comparison logic. Why to use equals method? Uh, okay. No, I'm talking about this method. You see, we can define our own method. So why to go with the equals method itself? Can't you define your own method and give any name you wish and parameters also you wish? and write the logic to compare the objects of this class. We can do it, right? Why we have to override equals method only? That is my question. Hope everyone got the question, right? Why we have to override equals method itself? It is in Java, it is recommended. In Java, it is recommended that you override or you use this equals method to write to compare the contents of two objects, to check whether the contents of two objects is equal or not, to compare or to check whether the contents of two objects is equal or not. We use equals method here. Okay, so but why we have to use equals method only? That's my question. Okay, I'll tell you people, you know there is a good reason for this. Let's try to understand. So it is recommended that in Java we use equals method to compare the contents of two objects, to check whether two objects are equal or not. We use equals method. You see, this way, first of all, Java is trying to standardize the way the objects are compared. Java is trying to standardize the way objects are compared. Yes, it has been standardized here now, I can say. That means everyone is going to use the same method, right? So if you define your own method, then it would take some time for others to understand that, okay, you have defined equals method. Or let's say you have written that logic to compare the objects. It will take some time for others to understand. But you see, now everyone will use the same method. That means they will override this equals method. So it is standardized. Now it's a common method which is used by all the developers in Java. It will be easy for you people to also implement it, because you know that now every time you'll implement it almost similarly. So now everyone knows that here we have equals method for comparing the objects. We have equals method for comparing the objects. To check whether two objects are equal or not, we have equals method. That is the reason. Okay, yes. Is this point clear for you people? The way the objects are compared in Java is standardized. Now everyone will be using this method. No matter they are what type of objects, all the objects, we compare them using equals method. Okay, but the logic, we need to write it. We have to override that equals method. Is this point clear, all of you? Any questions in this regard? Line number 25. Okay, you see, when you're calling the equals method, you'll pass that item object reference. So that object reference is stored in this reference variable, superclass reference variable. So whenever you're supposed to store that, we have it in superclass reference variable, right? I'm sorry. Now we have to store it into subclass reference variable, item class. Object class is superclass. So this reference variable obj is superclass type. We have to store it into subclass variable. For that we use casting operator, as we have discussed. If you remember, subclass object reference, storing it in superclass reference variable. Again, if you want to store that reference back into subclass reference variable, you have to cast it, use casting operator. That is what we are doing here. Okay. So the equals method signature, this is how it is defined. So that parameter type will be always object type. So we will take that reference and you have to convert it into appropriate type here. Hope you got it. Yes, typecasting itself. It's a typecasting operator, right? So which we saw earlier. The same thing. Okay, fine. Now there is one more point which you need to understand. Maybe sometimes people will realize and some few people may not realize it. Let me just point out. You know, why we have to implement that logic to compare the objects in the equals method? You see, why Java is not providing that comparison logic in the equals method? You see, by default, Java is providing this object class, right? And Java people itself are defining this equals method. And the functionality of equals method is same as double equal to operator, right? Why Java people, or they're not providing the functionality in the equals method to compare the objects? Why we have to write that code explicitly? Why we have to always override that equals method and write the logic? Why the object class is not providing the functionality to compare the objects? What do people think? Yes, that's right. Very good. Exactly. Because you see, object class is not providing the functionality, because from object to object, you see, from object type to object type, the way we compare the objects will differ. The way you compare savings objects will be different from the way you compare item objects. The way you compare item objects will be different from the way you compare employee objects. The data and its types, everything will be different from object to object. Object type to object type, I can say. So that's the reason why it is left to us. We have to override the equals method based on our requirement, based on the class, based on that object type. Accordingly, you will write that comparison logic to compare that objects. Okay, yes, this is another important point which you need to know. So by default, object class is providing equals method, but the logic to compare the objects we have to write it, because for every class or for every type, that logic is going to be different here. That logic is going to be different. Just a minute, please. Just a minute. Yeah, I'm sorry. So now, there are certain rules which we need to follow for equals method. You know what? I'm going to spend a lot of time here in equals method itself, but for other methods, you won't take much time. Let's go through the equals method. Okay. So we'll refer to the Java documents, Java docs, or we say Java API documentation or API specification. You see, now what you're looking at is Java platform API specification here. It's Java platform API specification. Just a minute. Yeah. So you see, this is your Java documentation, API documentation. This is not your API. It's just the documentation of the API. You see, these are the various packages which you will find in the API. So we have java.lang package. As I told you people, this is the fundamental package here. In the java.lang package itself, you'll find this object class. Here it is, you see. Object class is the root of the class hierarchy. Every class has object as a superclass. All objects, including arrays, implement methods of this class. Includes implements the methods of this class. You see, here these are the list of methods. You have method summary. In the object class, we have this methods. So one of the methods is equals, you see, equals method. Okay. So when we talk about equals method, you see, there are certain rules which you need to follow to override the equals method. First of all, what it says indicates whether some other object is equals to this one. You see, actually we call them as equivalence rules, which are supposed to be followed here while overriding the equals method. I can say we got some equivalence rules which we need to follow. What are they? Let's see. Equals method implements an equivalence relation on non-null object reference. What is this non-null reference? First of all, we'll try to understand this point. Non-null reference. Let's see what is it. Non-null reference. Non-null reference. Here, I can say that item 1 and item 2 are non-null references. That means in that reference variables, null is not assigned or null is not stored. In that reference variables, null is not stored. Okay. For suppose if I do this item, say item equal to null. Now I can say that in this is null reference. Item is null reference here. Okay. Null reference. What is null? What does it mean? What is null? Null means nothing. Null means absolutely nothing, I can say. Yes. Okay. Now this is null. This is non-null reference and this is null reference. Okay. Non-null means the reference variable which it doesn't hold any reference, which holds some reference which is not null. A reference variable which holds some reference which is not null is called as non-null reference. Okay. That means which is referring to some object, I can say. Non-null object reference means the reference which is referring to some object. Okay. which is not referring to null. Non-null means which is not referring to null. Okay. Now you see the equals method has to satisfy this equivalence rules. So first of all, we have this rule. It is reflexive. It is reflexive. So what does that means? For any non-null reference value x, that means if you have a reference variable, non-null reference variable x, if you have any non-null reference variable x, then x dot equals of x should return true. X dot equals of x should return true. Let's see. That is what reflexive means. So here, item 1 is non-null reference. I'm sorry, just a minute. Item 1 is non-null reference. Item 1 dot equals of item 1. That means self comparison here. Comparing it with itself. Comparing with itself. In this case, the equals method should return true. Okay, it should return true. Let's see whether our equals method returns true or not. See, it returns true. Yes. Okay. Next, this is the equivalence rule. Sorry, reflexive. This is one of the equivalence rule here. Next is symmetric. What is it? For any non-null reference values x and y, x dot equals of y should return true if and only if y dot equals of x returns true. Just read it once. Yeah. So hope you people got it. That means if item 1 dot equals of item 2, it should return true if and only if item 2 dot equals of item 1 also returns true. Item 2 dot equals of item 1 also returns true. Okay. For suppose if this statement returns false, then this statement what it is supposed to return? False itself. Yeah. You see, in both the cases you will get true. That is symmetric. Hope you people got it. Next, it is transitive for any non-null reference values x, y, and z. We can say that equals method is transitive for any non-null reference values x, y, and z. If x dot equals of y returns true and y dot equals of z returns true, then x dot equals of z returns true. That means, let's say if you have three objects, if you got three objects. So in that case, if item 1 dot equals of item 2 if it returns true, and item 2 dot equals of item 3 returns true, then item 1 dot equals of item 3 should also return true. Item 1 dot equals of item 3 should also return true here. Yes. So in all the three cases, you should get true. Let's run this code. Then we can say the equals method is transitive. Next, we got consistent rule. So for any non-null reference, we can say that equals method is consistent. For any null reference, values x and y, multiple invocations of x dot equals y consistently returns true or consistently returns false. Provided, I can say that the equals method is not modified between the comparisons. That is what the rest of the statement says. Provided if the equals method is not modified between that method calls, then it should always return same result. It should always return same result. Okay. So how can I show this here? Let's see. For suppose if I do this, we'll try to compare both the objects, item 1 and item 2. So you know what, in this case, it should return the same result consistently, either true or false. Let's see. Next, what is the other rule? Let's see. So the last rule, let's see what is it. For any non-null reference values x dot for any non-null reference value x dot equals of null should return false. X dot equals of null should return false. So what does that means? Let's see. That means if you compare a non-null reference, an object reference with null, I can say in other words, then in that case it is supposed to return false. The equals method should return false. Okay, so let's see whether it returns false or not. It is not returning false, but instead you're getting a null pointer exception here. Okay, why we are getting a null pointer exception? So we have to modify this code. I'll tell you. So you see, we are passing null to that null reference to this equals method. So in this variable obj you have null reference. That means that null reference in turn is assigned to this item 2. So using that null reference, you're trying to access the variable null.id. So whenever you use a null reference to access a variable, an instance variable, or if you try to call any method, then you'll get null pointer exception. You'll get null pointer exception. Yes. Okay. You'll get null pointer exception. Okay. Yeah. Yes. So what to do? We have to avoid this. We should avoid using null reference to access any instance variables or methods. So that's the reason why, first of all, we'll check whether that reference is null, if it is equal to null. So if it is, sorry, if it is not equal to null, if it is not equal to null, then only we'll use it. Otherwise, we'll not use that reference. So in this case, if item 2 is not equal to null, that means if it has got some reference, then only this condition will execute. Otherwise, it won't. Simply false will be returned. Yep. So this time, let me run this code. Yes, you got false. So we have achieved it. This is what we need to do. So hope you people got it. So anyone got any questions? So these are the equivalence rules which you need to follow while overriding the equals method. Okay, good. So hope everyone got it. Yes. So now let's move on to the other methods. We'll talk about other methods. Let's talk about the other methods in the object class. I have a request. Try to all of you try to override this equals method. Okay, override the equals method. You see, I gave you people some tasks. You might have already defined that classes, right? Yes, make sure that you try to override them. Next we'll move on. We got hash code method. You see, what is the return type of this method here? What is the return type you see for this hash code method? It's integer type, right? It's integer type here. Hash code method, when it is invoked, it returns a hash code value of an object. Basically, that hash code value is an integer value. Okay. So that hash code method, where it is defined, yes, where it is defined, hash code method, in the object class. Okay. So hope you people remember. Still, we are talking about object class here. So this method, when it is invoked, it returns a hash code value. Basically, that hash code value is a randomly generated value, and it's integer value. It's an integer value which is randomly generated. You see, this is your hash code value. Now, is anyone aware of this hash code method, like why it is used? What is the purpose of hash code value? What is the purpose of hash code value? No idea. And actually, what is this value exactly? I'll tell you people. You will find that the hash code method of the object class, it returns this hash code value, right? Internally, this hash code value is generated using a hashing algorithm. You have a hashing algorithm which is used to generate that hash code value. So that hashing algorithm, it takes the memory address of an object as input. The hashing algorithm, it takes memory address of an object as input and returns the hash code value, I can say. Okay. So hash code method, hash code value, how it is generated. Hash code value is generated by an hashing algorithm. That hashing algorithm, it takes memory address of an object as input and returns the or it generates that hash code value. Okay, so you have a hashing algorithm. It takes memory address as input and randomly generates that hash code value. There is no right or wrong thing here. Okay, we don't have to compare it with anything else. So the purpose is different. You'll find that hash code or hashing algorithm, if you pass a value, input value, something like x, for that x value, it always returns or it always generates the same hash value. Okay, uh, it is not used for security purpose, but as yeah, but I can say that it is actually used in collections, especially it is specially used in collections in case of set collections. In set type collections we use it. Yeah. Okay, so how it is used in set type collections and all, I'll tell you people later on. Okay, we'll see that later on. So yes, you see that hash code value, it is generated by hashing algorithm and it is generated randomly. So that values will be random values. Yes, not that means every time that a hashing algorithm it generates a random value which will be not related to the previous value which it has generated. Most of the times they'll be random. Okay, yes, so as of now you can make a note of it. Hash code value of an object is used to store them into set type collections. Basically we use it in set type collections. We'll see that we have a data structure called as hash table. We have a data structure called as hash table. There we'll use it. Okay, as of now you see, um, because the memory address of each object is different, you'll find that you're going to get different hash code values. You see, they won't be same. There is very less possibility that hash code value is the same. You see, they're all different, right? So that is the default behavior of the object class hash code method. So object class hash code method will take hash code value, sorry, memory address of that object as input, and it generates the hash code value. But you know what? When it comes to string class, hash code value is generated in a different way. How it is generated? You will find that in the string class, hash code value is generated. In the string class, hash code value is generated based on the content or the data which is stored in that object. Input for the hashing algorithm will be the data. Yes. You see, in this case, both the objects have got the same hash code value. For both the string objects, you got the same hash code value. So why the hash code value same here? Because both the objects have got the same content. The hash code value is generated based on the data. So data is passed as input to the hashing algorithm. Data is passed as input to the hashing algorithm. Okay. So you know what? I want you people to also do this. There is a reason for that. You'll understand it why the hash code values are generated based on that data, okay, which is stored in the objects. But I have a task. I want a strong yes or no whether you will be able to do it or not. Please tell me. I want you people to override hash code method in the item class also, such a way that it reads this, it takes this object's data as input and generates hash code value. I want you people to override hash code method in the object class such a way that it takes objects data as input and generates hash code value. Will you people do that? Very good. I want you people to do this, all of you. Okay. Okay, good. So we'll discuss about the rest of the methods in the next class. Okay. So I thought of extending, but today I want you people to. I will talk about it in the next class. We got some complicated methods which I would like to talk about it in the next session itself. Okay. So we have a session tomorrow at same time, and we'll continue our discussion at our regular time. The meeting link is going to be same every day. So we have a class tomorrow at same time, and we'll continue our discussion. Okay. Meanwhile, please try to complete the task and submit them.